Thank you. Fine. So can we start now?
Yes, if no one joining, then can we start?
Yeah. So Jeff may be, joining in later because this
Okay,
class is
fine.
not free for everybody. It's,
Hmm.
these are the already registered one and you are the interested one, maybe what I heard. So that is the reason you received this link. Okay,
Okay,
fine. So if you talk about F5 GTM or DNS, this is an again introductory class. Okay, very first class where we need to be gonna talk about the very basic foundation thing, and slowly and sooner we will be gonna pick the pace on the F5 GTM as well. But today is literally a very basic stuff we would be gonna touch. Okay, and I want that all of you should be participating whenever I am asking some question to have the session. Maybe just it should be both ways, not from my side only. Okay, it should be an interactive one. Fine. So DNS is the general term everybody is aware. Okay, it's not the F5 DNS only, but we are aware about DNS, that is a domain name system, and everybody is aware it's FQDN to IP thing, right? So base is that, crux is that, but in if we will go deeper, we will be able to see that there are a lot of things what we can do in the DNS as well. So we are aware that when a user enter the domain name into the web browser, request go to the DNS server, and DNS server determine the IP address by checking its lookup table and send the request information to the user so that it can be get, like, the user can go to the web server. But before that, because you people are already having more than 20 years of experience, I think you are already aware about those things. We will not be gonna use more time. But if somebody from here to here wanted to have some discussion, this is a system A, this is a B. It can be a user, it can be a server. Okay. How the communication flows? You people are aware, very well aware that there is something named as OSI model, which is now TCP/IP. So first layer 7, layer 6, layer 5, maybe we can have data. Okay, data segment is there. Then from there, layer 4 will come, which is again the segmentation we can say. Layer 3 will come where the network packet will get created, right? After that, frame, and then bit and byte. Actual bit and byte traffic will be get transferred. That is how your traffic will move from one place to another. Yes or no?
yes.
So if a user wanted to get the access to maybe google.com, let us say, okay, in that case, that specific person at the layer 3, when packet is getting formed, actual packet is getting formed, there is an source IP and destination IP kind of thing. He or she should be aware about the destination IP. If destination IP is not there, packet cannot be formed. And if packet will not get formed, then the communication cannot go through. And that is where the DNS is coming in between. And for a successful communication, DNS plays a very important role. Right? Let's proceed. So somebody joined with the name of user. Who is that? Jeff, is this you?
Yes, it's me. Nice to meet you. Thank you. I'm wrong in my time. I start. I thought it's 8:30, but Brazil time, but it's 8, right? No problem. Go on. Thank you and nice to meet you. Hello, Michelle.
Yeah.
Hello,
Fine.
Jeff.
Hello.
Hello, Jeff.
Thanks for
Oh,
joining.
hi. Oh, thank you. Thank you for everything.
Fine. Fine.
Yeah, Reda just started in, I believe that some minutes ago.
Right.
Oh, no problem. No problem.
Okay. So as I was mentioning you, this is a simple, introductory class, not a very deep thing, just to make you aware, like how we teach, what kind of, ways
Right,
we are.
right.
having.
Thank you,
Okay,
thank you.
let's talk about the DNS history. Okay, so DNS, as you people are aware, it's not a new thing. In, let us say, in 1970 and 1980s, actual, maybe not actual DNS will get formed, sorry, would get formed at that time. But in early 1970s, there was something named as host.txt. You people are aware about it? Host file?
Yes, sir. Yeah,
So host file, maybe you can say local to your machine, even your Windows file or any Windows server or maybe any Linux server have local host files. Let me give you an example. See, during the migration, we found a very peculiar stuff. What was that? We were supposed to have some maybe firewalls in between, okay, to the application servers, right? So earlier their traffic was going directly. Now there was some firewalls, there was some WAF device, and maybe lot of security standards need to be get introduced as per the requirements. So what we did for this xyz.com, okay, we created this uh, DNS entry for the firewall. Let us say the firewall IP is 222, actual server IP is 1.1.1 and 1.1.1.2 for server 1 and server 2 respectively. Okay. So during this migration, earlier maybe the people were going to some floating IP. I am just again taking an hypothetical IP 1.1.1.10. So users were coming to 1.1.10 and they can move to maybe server 1 or server 2 respectively. But now, as per the standards, we need to put the firewalls, WAF, and lot of stuff. Okay, so we make the changes into the DNS. And from their side, from server side, what happened is when they wanted to connect with server 1, they were utilizing the same, link like xyz.com. So even for the internal communication, they were going back over here, from here to WAF, from WAF to again, they are going, to their internal servers, which was not good. So what we did, we made the changes into the local host file of the servers. So when I was talking about the host file, I just, recall that stuff like how a simple host file entry can save a lot of hours of this, peculiar issue to get resolved. So host file means very first, your device will check any kind of cache entry, right, in the DNS, or then host files. And in 1970s, as I was mentioning you, okay, the host file was the solution. So Paul and John developed this DNS concept in 1983 later on to automate this whole process, because earlier these host file were local to the PCs, and later on maybe in a corporate there was somebody who was maintaining this host file, push this host file on all of the PCs so that they can surf the internet. If there is no entry, they cannot go to the internet. So we need to modify it. It was really very complex thing. Yeah. So what I was mentioning, in 1970s and 1980s, there was some host file stuff which still, present, but currently we are utilizing the DNS. We are not reliable on that. So DNS, if I will talk about, in 1984, DNS implementation, first implementation come into the picture. As per your RFC, if I am able to recall, is 882 or 883 was the RFC numbers. As per that, this come into the picture. And in 1980s, if I will say in 1980 or 1990s, there was an era where internet start, picking up the pace to grow rapidly. And there, uh, have you heard about Bind?
yes,
Yes.
bind, yes.
It's
Bind
Bind.
DNS.
running
Yes,
under Linux.
yes, exactly.
Yes, 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 yes. So bind is Berkeley Internet Name Domain, right? It emerged into the picture, and it's becoming a very widely used DNS server implementation those days. Okay. Then again, as time passes, maybe let us say 1990s to 2000s, right? The commercialization of the internet led to a rise of domain registrars and maybe DNS service providers. And here your top level domains come into the picture, which are further expanded your DNS. Then DNS security come into the picture because there was lot of vulnerabilities get introduced. And now in today's time, maybe we can say from 2000s to the current or present time, DNS really is becoming a target for various cyber attacks, leading to ongoing efforts to have the security for the DNS. Continuing growth of the internets with billions and billions of the devices and the your websites which are coming into the picture. So overall, your DNS has evolved a lot, and it's a very very critical component of the internet infrastructure, right? Okay, I hope DNS history is fine. Let's talk about the DNS overview. I was talking about the top level domains, though I use that term, thinking of that you guys are already aware. If not, maybe we can discuss about the same. If yes, you are aware, please you do let me know. What is TLD? What is SLD or second level domains or top level domains? Any idea, whatever. Okay, this is not an interview. So whatever you aware of, you can please tell.
I'm not so a
dot
lot of
com,
aware
dot
regard
root
TLD.
domains.
Okay, it's all right. Shirini,
Yeah,
you were
it's
saying?
like root domains and all these terms comes in dot com, dot something, a root domain, subdomains, all.
Yes, 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 yes. So let us take an example. www.google.com. Okay. Post that actually there is a hidden dot. Okay. Always. Maybe www.netminion.net. Dot net. Okay. Maybe www or anything. Dot EU. Dot FR. Dot uh, IN for India. Maybe country basis can also be there. So what you see here, this thing, okay, these stuffs are the top level domains. Or with respect to the DNS, maybe you can say these are the highest level in your DNS hierarchy. How DNS hierarchy even form is a bit, maybe you can say reverse root structure. I would be gonna show you maybe in the other diagrams. Okay. So on the top, there would be a root thing. Root is what? This dot, hidden dot. Okay. After that, maybe your top level domain like .com, .net, .org, .net, or .in, maybe any. Okay. UK, EDU, government, GOV, okay, .org. So anything. So these are your top level domains, right? From top level domains, how your if I will say the regulation happen, okay, although we will be gonna talk a lot about it, from here to here, which means from right to left direction. So very first it will go to the root, then top level domain, then second level domain. Okay, and there can be a number of tertiary domains maybe we can have, right? So okay, because we are talking about root, there is something named as root servers. Okay. So anybody wanted to talk about root servers?
Yep,
Root
you can.
servers? Yeah.
Yeah.
Go ahead, Mission.
No, sorry, you can talk about root servers.
Okay. Root server is nothing but maybe like as I was mentioning you, like www.google.com and then dot is there, right? It is a root. So root server, again, a critical component of your DNS infrastructure, or you can say they are an authoritative name server for DNS root zone. Okay. So in the top, there is a root. Root will forward to .com. .com will forward to .google. Then maybe if you have some blog.google or maybe some sales or maybe some marketing or whatever, you can go ahead as per the different ways. The concept of root servers, maybe I will say, dates back to the early days of the internet, with the first root server being implemented again in 1980s. Okay. And again, as per your host file, was growing very much. So this root server come into the picture at that time. But later on, to improve the resiliency and scalability, it was required to have multiple root domain servers rather than a single root domain server, right? So what happened? Maybe now also you can see there are 13 servers naming from A to M. Okay. But currently there are, more than 13 servers, 13 root servers, and the operation and management of the root servers are distributed among different organizations worldwide. Okay. Who take care of it? IANA. Okay. And ICANN. Right. So it is Internet Assigned Numbered Authority. Okay. It is Internet Corporation of Assigned Names and Numbers. So these are the responsible, I will say, for overall coordination among your DNS root zones. Okay. Including the allocation of IP address also. Right. So everything would be gonna take care by that. Fine. So far? Okay.
Yes,
Yeah,
okay.
that's fine.
Right. So how your DNS work is, let us say this is a client. Okay. This client wanted to go to some of the website. First, as I told you, it will check its host file or maybe caching thing. If not found, maybe you are in the home. I am just giving you an example. You should have some modem or something, right? So your packet will go to the modem. It will ask to the modem because modem is the DNS for you. So it will ask, hey buddy, do you know this maybe dub netminion.net? I wanted to know about this host. Are you aware about it? If yes, it will give the IP. If not, then this query will go where? To root server. Root server say that, okay, it is .NET. Buddy, go to the .NET. Then go to the NetMinion. Then NetMinion will, maybe there is a NetMinion server there, which will give the IP. Let us say the IP is 1.1.10.1, anything. Okay. And that will get resolved. Then another packet will go to the application which is hosted in the NetMinion data center. So there are two packets. One packet is for what? One is for DNS. Second is for what? Second is for your actual application traffic. It can be your GET request, it can be your POST request, or maybe whatever request you are going with. Fine? Okay.
Okay. Thank you.
Yeah. Tell me. Any question?
No questions
No question.
from my end.
Fine. Now, I will say this modem is what? It is bit like DNS recursor. Okay. This modem is what? DNS recursor. DNS recursor, maybe you can thought of like a librarian who is asked to find a particular book. Okay. And this DNS recursor, let me maybe write down. DNS recursor. Okay. Bit like a librarian. That, okay, I wanted to find some book. And this recursor is checking its maybe all the queries through a book or through a dictionary or maybe something or some file, okay, which is your root. Root is root server is maybe first step in translating the human readable host name to the IP address. Okay, it can be thought like an index, maybe I can say index of your library that point to the different racks of the book. So root never give you the IP address. Please be aware. What it give? It give you the reference like on which rack this book can be located, right? So it will forward to the specific rack. Okay. What is that? That is your top level domain. Because .NET I talked about, right? Like .org, .com. These are your top level domains. So top level domain name servers can be thought like as a specific rack of book library. Still, your book is not found, right? It is a complete rack that, okay, in this on this rack, there can be a book. So this name server is the next step in the search of a specific IP address, but still it need to give you the actual book, which you can get like on which shelf it is, it NetMinion can give you. And this is named as authoritative name server. Fine.
Yeah.
Yeah. Mhm.
Perfect. So this is what I wanted to show you earlier, right? So you can see DNS is bit like reverse root, reverse tree, I would say. So root is on the above, okay, and then branches are going below. Okay. So on the top, what is there? Root server. Then your top level domains. It can be edu, it can be .com, it can be .org, anything. After that, you can have maybe f5.com, sun.com, netminion.com, anything. Within F5, okay, there again, within this domain, there can be a lot of zones file. What the zone files are, we would be going to talk, don't worry. Okay, so there can be a lot of zone files depending upon maybe your area to area. Let us say there is a sale area. You have different zone file for the complete sales group. For marketing, you have different. For products, you have different. For services, you have different. For HR, different. Hiring, different. So depending upon your, maybe I will say organization, okay, how big your organization is, you may have multiple zone files depending upon that, right? And as I told you, your name will be given a resolve from right to left. So if you see this specific name, how it is getting formed, first dot, then com, then F5, then maybe if it is a tech, you can say tech. And that is how it is resolved from right to left. Any question?
No question from me.
Perfect. So if I will be gonna talk about, DNS lookup process. So as I was mentioning you, now let me completely tell this. This client is going to google.com. Where this will go? First of all, it will go to the local recursive, right? Yes or no? So very first point, it will open the browser, put this name. Second is it will go to the local recursive. If local recursive does not have that, it will go to the top level domain, or before that, maybe I forget about the root. It will go to the root. From root. Okay, so let me mention the point, the www.google.com. Then second, local recursive. Then third, root domain. Root domain will forward it to the top level domain. From top level domain, it will go to the authoritative name server. And from there, this resolution will, actual IP will receive. Okay. This actual IP will go to the client who was asking for it. And in the 8th step, this client can go to that specific web server if you want to access some application, right? That is what we discussed. Yes or no?
Yeah, that's right.
Now,
Right.
here, when we are doing this, in this DNS, there are lot of queries come into the picture. Okay. So this following DNS, stuff can be divided maybe into couple of the queries. The very first query is named as recursive query. Okay. So what are these recursive query? Recursive query take between the recursive server, which is maybe your model, okay, and the client. Here, either the answer can be provided, right? Or there can be maybe some error can also be there, or there can be iterative DNS queries that can happen. Iterative DNS queries are what? Which are between your recursive resolver. Please be noted. Now, client won't go to the root. Who will go to the root? Your recursive resolver. So your modem, in your case, will go to the root, and then all of this stuff which is coming up, this is named as iterative query. These two types of queries is okay for you? Any doubt? Any question, guys?
No, sir, it's fine.
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 Perfect. So these were the really very basic. Now let's jump to the overview of F5 GSLB. So what is this GSLB? Anybody?
Global server load balancing.
Yep. Global server load balancing, but in generic term, what is this all about?
Yeah, it's to provide the faster resolution and the routing to resolve the names.
Correct. Anybody else? Fine. Yeah. Jeff, you wanted to share your views? Go ahead.
No, all good. Yes, it's correct. It's a distribution between the global to the company or internet.
So let's talk about the SLB first. Okay. Server load balancing. Again, very simple thing. It is a technology that distributes high traffic sites among several servers, backend servers, I would say, right? So if there are multiple of the clients which are coming, right? They will go to the F5 LTM. F5 LTM in turns, there can be multiple of the actual application server. I am just creating two for the ease, and the traffic can go to any one of them depending upon they should be up and running and healthy in the stuff, right? That is how your server load balancing works. But in case of GSLB, right? First of all, this every stuff what I am talking about is local to a data set. When I put GSLB, it is not local to a data center, but there can be multiple data centers. This point is clear? And that is the reason it is named as GSLB. Now what happened is, let us say you are hosting an application, and again application name is abc.com. You have some servers for this. Okay. I am just creating two servers. There is your LTM and there is your VIP. LTM VIP. Again, I am taking some IP name with 443. Okay. And it is going to maybe both of them. This is your APAC region. Then you have one more data center. Or maybe let me change the color. You have one more data center. You are hosting the same application there. Again, you have LTM. Okay. Maybe you can have a VIP 2.2.2.2. And you have two servers, server number 1, server number 2. Here also server 1, server 2. Now, this is a user. Okay. This is a user. This user wanted to go to abc.com. Can any one of you just describe me whatever we discussed before, how the communication will happen and what IP it will get? Just try anything. It's not interview. Just to make the session interactive, I wanted your support.
Sorry, what was the question?
So this is a client user.
Mhm.
Okay. This user wanted to go to abc.com. So what we discussed about the DNS lookup and all, maybe you can just define how it will get the IP and what.
Yeah, the user will communicate with the request will send to the local DNS.
Yep.
Yeah, after the local DNS, they will after that they will carry to recursive DNS server.
Like root.
Yeah, root server, and after root server, we'll send the query to the, for example, to the GSLB, to the right
top level domain, which is .com. Okay. .com will send it to the ABC name server. Okay.
Right. It's a sequence of. Sorry for interrupting. It's a sequence of queries, right? So you send local first. After that, you recursive send another query to root, and a root sent to TLD, right? And after that to server names, right? It's a sequence, right?
Right.
A normal sequence.
So now see here. In this ABC name server, let us say there are two IPs, 1.1.1.1 and 2.2.2.2. Why there would be two IP? I need not to explain. If I need to, please tell me, I will explain. Okay, maybe let me ask this question. Why there are two IPs?
Okay, they are resolving two IPs.
Why we need two IPs here?
Yeah, it's the primary, the other one it's secondary, right?
Because you have two data centers, right?
Perfect. And I will say both are primary.
Right, you have two primaries, but you needed to put a way, right, to choose, right, one or other.
Yes.
Like Michel says, primary or second. You need to define who will be, what will be the primary or second, right? Because
So
we have two primaries.
Both are primary. Both are primary.
All right. Yes, both are primary. I have is
Yeah.
the sum.
But it
right?
will, yeah, but it will depend on of your GSLB rules, right?
So currently I am not talking about any GSLB concept. I am just saying that this is a some file or some maybe Linux based bind, let us say. We are utilizing bind utility. So what should we do? That is my question.
You needed to put some wave or metric to
yes.
Mm.
Perfect. You are going
right,
there.
right.
Now, what I am trying to say is, if this is a case, sometime this user can 1.1.1.1, sometime this user can 2.2.2. right?
Right.
But it should not be the case. Let us say if this user is from US, okay? Instead of going to the US data center, it is receiving 1.1.1. That will increase the latency. No? And if this user is, let us say, from India or Singapore, and this user is getting 2.2.2, again the latency will be getting introduced because your whole packet will move to the another continent.
Right.
And
Makes
there
sense.
is when F5 come into the picture. I am just trying to talk about the GSLB concepts.
Yeah, this concept that you're talking about, it's a topology, right?
Yeah. So this is the DNS concept, right? So now what happened is, let me talk. Your request will, after this name server, instead of going there, let me rub this. Here somewhere we will be using F5 GTM. So your request will come where? On F5 GTM. F5 GTM will have some entry for abc.com. Okay. This abc.com has two IP address. One is 1.1.1 and second is 2.2.2. Are you getting my point? Now F5 is an intelligent DNS solution. It will check either the user is from this continent or that continent. It has whole list even of the public IPs that will check, that can check the source is where. Okay. Depending upon that, if user number 1 who is nearby the APAC region will have the IP resolution as 1.1.1 for the same application. If the user is nearby to the US continent, it will receive the IP 2.2.2. Just for your fast, response, low latency, low delay. And this GTM is dividing your traffic among the data center. That is the reason it is named as GSLB, Global Server Load Balancing. Add it up. Michelle, Shirini, Jeff,
But
is it
application
clear?
has only IP address, one IP address.
Sorry?
But application has only one IP address and one URL.
No. Yeah, URL is single. Yeah, URL is single. Even even URL can be more. Okay, we can create LICs also, but that is a different thing. I don't want to get a complexity on the first class. But for now, I am just not introducing that concept of C names or something. I am just saying one host name to different IPs.
Okay, fine.
Okay.
Okay, fine.
Yeah. Michelle and Jeff,
Yeah.
add it out.
No, that's okay from my end.
Yes, that's okay for me as well. Yeah, thank you. Yes.
Okay, so there is where like GSLB will come into the picture. Now, you guys must be aware when you are using F5 LTM, you are creating a virtual server and you have a pool, right? And there can be different pool members. And you do the load balancing between the pool members. That is how you do, right? But in case of your GTM, there can be different pool and inside the pool there can be different pool members, which again we will be going to discuss in very detail later on, but I am just giving you an example that now in case of GSLB your load balancing will come pool level, and again from pool it will come pool member level as well, two times. Here single times. Okay, but again that is a separate story. I don't want to get into that, but if you have any question you can ask, please.
Yes, sir. I have a question.
Go
Here,
ahead.
the pool members are the virtual LTMs, virtual servers of LTM. Maybe
Yes,
one is India, one is US,
yes,
and yeah, this is monitored by HTTPS, water monitoring
yes,
mechanism, which it
yes,
will check all the query with the GTM.
yes. So let us say
Yeah.
this is Europe region and APAC region. You can have a Europe LTM and you can have an APAC LTM virtual server, right? Here also maybe you can have North North America and South kind of thing. So you can have one here North and then South. Okay, these are the virtual servers. Now depending upon your configuration, okay, either you will go to the pool one or pool two. Then within the pool there can be different pool members. So where actual traffic will go, what IP that user will receive, depending upon a lot of conditions. If else are there can be lot of if else. Fine.
Yep, that's fine.
Yep, that's fine. Mhm.
Yeah, good
Okay.
example that you did.
Yeah, fine.
Yeah. So this is the thing like what I wanted to show you in the very first class. Then again, as you can see here for the code, like practice without the theory is really blind, and theory without practice is again still, right? So you will get a lab to do a lot of practice. Okay, you need to use your number of hours wisely. And here you can see we are having some Linux servers which can be used as the app servers also. And in earlier days of our class, we will be creating the bind, and I will try to show you the zone transfer class and everything from local bind server to the GTM. So we will be using them as app server and the DNS server as well. Okay, so we will create some zones on the Linux machines, and I will try to show you creating the records like a record, quad a record, what are those? Okay, blah blah blah. So we will be play around a lot of things. Then you can see there is EMEA and APAC topology we are referring over here. So we would be creating the generic host also. We are creating through big IP also. So there can be, when we are talking about the virtual server, there can be a generic virtual server. There can be going through the F5 LTM. Lot of, I will say scenarios can be created that we will be gonna teach you. Okay, using the lab is again very easy. Just right click and it will be get started for you. Okay, and when you just take the double click over here and you can see this device is booting up. So you need to do this topology from the scratch by yourself, right? So you will enjoy a lot when you would be gonna do all of the things with us. Okay, and it is over the internet you will able to receive it. Okay, and you can able to do the lab topologies. So as I showed you, this is our lab topology. Any question?
Oh no, no question
No
Fine.
question.
from me.
Yeah,
Fine.
fine from my end.
Okay, so these already you people are aware about our context and everything. So that is what from my side in today's introductory class. Okay, if you have any question, anything you wanted to share, any suggestion, please feel free to ask, feel free to share.
So when is class starting? You have any schedule, next schedule group class?
You can say officially today is the first introductory class.
Oh,
Okay, so from next Saturday, this class will start from the same time. And Shirini, just
so
FYI, this class
class
is
will be
only for
sorry, sir.
Saturday. Only for Saturday,
Saturday
not
and Sundays only, weekends only.
no, only Saturday. Okay, and in Saturday we will be picking up maybe 3 hours or 3+ hours. Then rest of the days you can just go through the videos and you can do your work. And again next Saturday. So approximately maybe we will be gonna cover it on the same time like our week if we utilize both of the weekends, because in the Saturday we can cover up more.
security day service. 3 hours means how many days? How many weeks? Like
Sorry,
but the whole course will be covering how many
hours.
weeks,
Okay.
Saturdays? Yeah, how
You
many
can
hours?
say you can say it is approximately maybe 18 plus hours or so. Okay. So it would be around 6 Saturdays or maybe 1.5 month, you can say. Okay.
Okay.
If we have any questions, can we reach you out by email or by WhatsApp?
Why
Rina?
not? Why not? Why not? See, when you go to NetMinion, when you go over here to the NetMinion, when you ping over here, it will lead to me only.
Oh, very good. Very nice.
Okay, so you ping me as I am telling, I am also a working professional. Maybe I cannot answer you then and there at once, but yes, I will give. Okay.
Oh, that's
All right.
nice. Sounds good.
Nice. Hmm. Perfect.
Very motivated.
One more
Mhm.
question.
Go ahead.
This APM advanced WAF class also going there. You will teach the same classes apart
APM
from
is
GTM.
APM is a different trainer. Okay, and he is
Yeah,
also a
advanced
working
WAF.
professional. Yeah, he is also a like working professional. So he is bit like associated with us from past 5-10 years. So he can teach you the APM. Okay, but for LTM, GTM, ASM, I can be your buddy to get it resolved or mentor, maybe whatever you want it to tell. Okay,
Talking about advanced WAF.
advanced web, that is ASM only.
AWS.
That is ASM only.
ASM. So you will be teaching advanced WAF.
Yeah, I would be teaching. ASM is like old name, like GTM is the old name. Okay,
Mm-hmm.
current name is FIDNS. Similarly, ASM is old name. New name is advanced web.
Advanced WAF. Okay. So yeah. Okay. Thank you.
Yep, yep. Sure. Okay, then let's wrap it up over here for today. We'll meet you next weekend, okay, with the
Oh,
full-fledged 3 hours or more, class, and
mhm.
then be ready. Thank you, guys. Nice to meet
Thank
with
you.
you.
Have a
Thank
good
you,
good
Red.
weekend and
Have
good
a
Okay.
good
good
week.
weekend for you too, guys.
Thank you
Yes,
for this
yes.
class today.
Yep. Great day.
Thank you.
Bye.
Congrats for the
Thank you
class.
very much for all.
Okay.
Thank you.
Thank you. Bye.
See you guys.
Thank
Bye
you.
bye.
See you, son. Bye bye.
Bye. Bye.